Welcome to Skyscope, the podcast for amateur astronomers who want more than just the obvious. We will bring you a new episode every Monday right here on this YouTube channel. Each week, we highlight one carefully selected target from faint planetary nebulae to off-the-path galaxies designed to push your skills, your optics, and your curiosity just a little further.
That's the goal, really get you looking beyond the usual suspects.
So grab your charts, check your skies, and let's get to this week's object. And just so you know, this particular observing tip is perfectly timed for calendar week 28. Get ready for, well, a cosmic spectacle that's not just visually stunning, but absolutely brimming with fascinating science.
Oh, definitely. This one's a classic for a reason.
For calendar week 28, we're setting our sights on the magnificent Dumbbell Nebula.
M27.
This is Skyscope. Challenging targets, real observing.
It seems to have quite a few names, doesn't it? We've got Dumbbell Nebula, M27, any others people might hear, like Apple Core Nebula, and NGC 6853.
That's right, yeah. It gets called the Apple Core Nebula sometimes, too. And its formal designation is NGC 6853.
It holds a really significant place because it was the very first planetary nebula ever discovered.
The first one?
The very first. And it was Charles Messier, the famous French astronomer and comet hunter, who found it way back in 1764. Okay, let's talk about actually finding this cosmic wonder. As you said, it's a rewarding hunt. Let's start with the bright signposts, the streetlights in the sky, if you will.
Good analogy.
First, you'll want to locate the bright star Altair. It's an Aquila, the eagle, one corner of the summer triangle, easy to spot.
Got it.
Once you have Altair, you want to move northeastward. Aim towards Albireo.
Albireo, that's a beautiful double star at the head of Cygnus, the swan, right? The other part of the summer triangle.
Exactly, the golden blue one.
M27 lies roughly 1/3 of the way along an imaginary line drawn between Altair and Albireo. It's firmly in Vulpecula. And for a closer pinpoint, look for a star called 14 Vulpeculae. M27 is quite nearby. That should help you zero in. It takes a bit of star hopping, but it's definitely doable.
Visibility-wise, it's actually surprisingly bright for a planetary nebula. It has an apparent visual magnitude of about 7.5.
7.5, so potentially binoculars.
Yes, exactly. Under good dark skies, away from city lights, you should be able to pick it up as a faint, fuzzy patch in good binoculars, like 10 by 50s or larger. But where it really starts to shine, no pun intended, is in a telescope.
Right.
Even a small telescope, say a 4-inch refractor or maybe a 6 or 8-inch reflector, will start showing that distinctive shape, that dumbbell or apple core look. And it's quite large on the sky too, relatively speaking. Its apparent size is about 8 by 5.6 arc minutes. That makes it one of the biggest planetary nebulae we can see.
Oh, wow. So it's not just a tiny dot.
Not at all. That size really helps when you're trying to find it and observe details.
Wow. So it fills the eyepiece pretty nicely at medium power.
It does. It's not some tiny speck you have to strain to see. It presents a really nice target.
Okay. And what about finer details? You mentioned knots.
Yes. This is where good seeing and maybe a bit more aperture helps. Inside the main nebula, especially in the central region, you can start to pick out these, well, knots. They appear as patterns of dark and bright cusped knots. Think of them as denser clumps of gas.
Like little blobs within the fuzz?
Sort of, yeah. And often they have dark tails streaming away from them, pointing away from the central star.
Like tiny comets inside the nebula.
That's a great way to visualize it. Some look quite symmetric with tails, others are more irregular, maybe tailless.
And what are these bright cusps on them?
Those are called local photoionization fronts. Basically, it's where the intense UV light from that central white dwarf star is slamming into the denser knot material.
So the edge facing the star glows brighter.
Exactly. It supercharges and illuminates the gas right there. It's like a little shock wave of light hitting the denser gas.
Okay, let's unpack this. With all those delicate details, the knots, the cusps, the tails, that specific shape, it sounds like there's a lot more to see than just a fuzzy patch. For listeners wanting to push their skills and really see that structure, what's the secret? Are there like tools or tricks? Filters, maybe?
You're right on track. Filters are absolutely key for bringing out detail in planetary nebulae like M27.
Okay, which ones?
Well, a good starting point, especially if you have moderate light pollution, is a UHC filter, ultra-high contrast.
UHC filter.
Got it. That blocks a lot of the general sky glow, but lets the nebula's light through. For an even bigger boost, especially on planetary nebulae, you want an OIII filter. Oxygen III.
Oh, III. Okay, why that specific one?
Because planetary nebulae like M27 glow really, really strongly at the specific wavelengths of light emitted by doubly ionized oxygen, which is what OIII refers to. It's a greenish blue light.
Here's where it gets really interesting for me. Beyond the sheer beauty and the challenge of observing it, What's the deeper story? What does the Dumbbell Nebula actually teach us?
M27 is way more than just a pretty picture. It's a window into stellar evolution, specifically the end stages for stars like our sun.
So it shows us what happens when a sun-like star dies.
Exactly. This whole nebula is the result of a star, probably a bit more massive than the sun initially, but broadly similar, reaching the end of its main life. It ran out of hydrogen fuel in its core, swelled up into a red giant.
And then puffed off its outer layer.
Correct. Over tens of thousands of years, it shed those outer layers of gas into space, creating this expanding shell.
And what's left in the middle? You mentioned a white dwarf.
Yes, the incredibly hot, dense core of the original star is left behind. That's the white dwarf. It's tiny, but incredibly hot.
And that's what makes the nebula glow.
That's the engine lighting it up. The white dwarf pours out intense ultraviolet radiation, and that UV light energizes the gas shell, ionizing it and making it fluoresce, making it glow.
It's like the star's final act is illuminating its own shroud.
Beautifully put. It's a temporary cosmic monument.
Now, you said the nebula is expanding. Is it like visibly growing?
On human timescales, no, not visibly in your telescope year to year, but astronomers can measure it very precisely over decades by comparing images.
How fast is it expanding?
Okay, there are two ways to look at it. First, how fast it appears to grow on the sky, the angular expansion. Studies, like one by Moreno Corral and others in '92, found it's expanding no more than 2.3 arcseconds per century.
2.3 arcseconds. That's tiny. Like less than the width of a coin seen from miles away per 100 years.
Something like that, yeah. It's incredibly subtle from our viewpoint. Based on that, they estimate its maximum age is around 14,600 years.
So we're seeing a relatively recent event unfold.
We are. And this brings us to maybe the most profound point.
Which is?
M27 is effectively a glimpse into the future of our own sun.
Our sun is going to do this.
In about 5 billion years, give or take, our sun is expected to go through a very similar process. Red giant phase, puff off its outer layers, leave behind a white dwarf, create its own planetary nebula.
Wow. So looking at M27 is like looking at Earth's distant future neighborhood.
In a way, yes. It's a preview of our solar system's final act.
For our listeners who love astrophotography, M27 must be a prime target, right?
Oh, absolutely. It's one of the premier targets for astrophotographers, from beginners to experts.
What makes it so good for imaging?
Several things. Its brightness means you can get decent data relatively quickly. Its large apparent size means it fills the frame nicely even with shorter focal length telescopes. And it's just packed with detail and color that cameras can reveal beautifully.
So even modest equipment can get good results.
Definitely. You can get started with a DSLR on a tracking mount and a small telescope and capture recognizable images. But the real magic comes with longer exposures. Long exposures reveal the vibrant colors, the reds, the blues, the greens, and all those intricate structures, the filaments, the knots, the faint outer halo that's often invisible visually. You capture that complex interplay of gases.
And do astrophotographers use filters too, like the OIII?
Oh, very much so, but often specific imaging filters called narrowband filters.
So they take separate pictures in each color?
Often, yes. This creates those incredibly detailed, vibrant, Hubble-like palettes.
That's how they get those amazing colors. It reveals the different gas compositions.
Precisely. It shows where different elements are concentrated within the nebula. It's both scientifically informative and aesthetically stunning.
So M27 is a fantastic target visually and photographically.
Without a doubt, it really offers the best of both worlds. It's scientifically important, teaching us about stellar evolution and cosmic recycling, and it's just breathtakingly beautiful, a rewarding challenge for observers and imagers alike. It truly is a window into the life cycle of stars and the dynamic nature of our universe.
What a fantastic object, a perfect challenge for calendar week 28. Well, if you enjoyed this deep dive into the Dumbbell Nebula and you're hungry for more challenging, beautiful, and off-the-beaten-path objects in the night sky, make sure to subscribe to our channel.
Yeah, lots more fascinating targets coming up.
We bring you a new Skyscope deep dive every Monday, packed with tips and insights. By subscribing, you won't miss a single target, tip, or opportunity to take your observing to the next level.
Keep looking up.
Thanks for listening, and until next time, clear skies and steady seeing.
This is Skyscope, challenging targets, real observing.